we have three similar triangles erected on the faces or the sides. So if we have A, B, C, and this is D, E, F. Now, the similar triangles, of course, we have to say which angles are equal to which angles. So we can say that this angle is equal to this one, is equal to that. This angle is equal to this one. Is equal to that. Okay, maybe I can change the red angle a little bit. The red angle needs to be one of the vertex angles. Okay, and then we have the purple angle equal to this purple angle equals to this purple angle. So what are we doing? Well, we are improving the theorem, or maybe looking at a special case of it. So what is the special case? Well, we have erected three similar triangles on the sides of ABC. We have erected three similar triangles on the side of ABC. We want to show that the circumcircles of AFB of these external triangles, circumcircles, pass through one point. This is very easy given what we have done up to now. The greens are equal, the reds are equal, and the purples are equal. That's given data. We can use what we have done already in the first theorem and prove this one. I mean, this is really a one-line proof. This is really a one-line proof, given the fact that we already know the first theorem. What can you say about the green plus the purple plus the red? What can you say about the sum of these three angles here? That this is just 180 degree. And we have already shown this, that if terminal angles add up to 180 degree, then the circles would intersect at a single point. This is a special case of that. We really did not need the similar triangles. We just needed the fact that the three terminal angles add up to 180 degree, which it does in this particular case. So this was an easy corollary of what we have already done. There is another one which is quite interesting. If you have a triangle ABC, let's take a triangle ABC. And suppose if we take the points PQR, or rather if we can start with PQR. Let's take PQR like this. Now let's take points, the vertices ABC of the triangle ABC, to lie on the sides. So this is A, this is B, and this is C. So we have this triangle ABC like this. So this is triangle PQR. Then the circumcircles of CBP, ACQ, and BAR have a common point. This is really a one-line proof again. So if you have this, if you have this, and if you have this, try using the first theorem again. Try using the first theorem again. This one, and that one. Angle P plus angle Q plus angle R is definitely equal to 180 degree because this is a triangle. PQR is just a triangle. And you can imagine that these three triangles are erected on the sides of ABC. So we have precisely the situation of the first theorem where you have a triangle ABC and where you have erected three triangles on the sides of it such that the terminal angles add up to 180 degree. And in this case the terminal angles add up to 180 degree because it's just a triangle. PQR is a given triangle. So the circumcircles of ACQ and ABQ and this one, they all pass through a single point. This point, I have discussed this point in some previous lecture. This is sometimes called the Meikle point. It's quite an interesting piece of information. In fact, this has a beautiful extension, and you can give it a try. If you have four straight lines, then, and suppose each of them hits the other three straight lines. Each of them hits the other three. So what you have is this. Three straight lines, maybe something like this, something like this. Or four straight lines, each of them hitting the other three. We can show that the four circles, there are four triangles formed in the process. So one is this blue triangle, one is this green triangle, and then you have this big red triangle, and then you have this one. The red triangle and the black piece. So there are four triangles in this system. And you can show that the circumcircles of these four triangles pass through one single point. So that means if you draw the circumcircles like this, then the four circumcircles will pass through one single point. Okay, maybe you can do this as a homework, and we want to pickles. So this is as a homework, right? This is a homework.